Welcome back to the Total Quality Management Training Series. In today's lesson, we're focusing on a critical tool for maintaining and improving quality across your operations. And that tool is control plans. Whether you're in aerospace, automotive, electronics, or any manufacturing sector, control plans are essential to translating your quality objectives into real-world results. So, let's jump in, starting with the basics. A control plan is a structured document that outlines how key characteristics of a product or process will be monitored and controlled throughout production. But it's more than just a checklist. It's a living tool that brings together your risk assessments, standard work, inspection procedures, and reaction plans, all into one central document. It provides the what, how, and who for each control activity. Think of it as the bridge between engineering intent and actual process execution. And it's not just for production, it can apply to incoming inspections, special processes, packaging, or even service and warranty processes. In short, a control plan answers three questions. What do we need to monitor? How do we monitor it? And what do we do when something goes wrong? Now let's talk about the value control plans bring to your quality management system. First, they support preventive quality. Instead of relying on detection after the fact, control plans help you monitor key inputs and parameters to prevent issues before they happen. Second, they provide standardization. When multiple operators, shifts, or sites are involved, a control plan ensures everyone is using the same playbook. Third, they improve audit readiness and compliance. Whether you're meeting ISO 9001, AS 9100, or another set of requirements, having well-documented control plans demonstrates your commitment to process control and risk mitigation. And finally, they support continuous improvement. By tracking trends in controlled variables and linking to your CAPA system, you can make informed improvements over time. So what goes into a control plan? Let's walk through the key components. Control plans are typically organized into a table. Starting from the top, the following is a list of the sections that should be included. Part or process name and number. This is the identifier for the product or process the plan is associated with. Process step or operation. Each row of the plan represents a specific operation, like drilling, coating, or final inspection. Characteristic being controlled. This could be a product feature, like hole diameter, or a process variable, like oven temperature. Specification or tolerance defines acceptable limits for each characteristic. Control method details how the process is controlled, for example, automated sensor feedback, SPC, or operator checks. Measurement method, how the characteristic is verified, calipers, CMM, pressure gauge, visual inspection, and so on. Sample size and frequency describes how often the check is performed and how many parts are sampled. Reaction plan. This is crucial. What happens if something is out of spec? Does the line stop? Is there containment? A root cause analysis? Responsibility. Identifies who performs the control, usually by role, not name. For example, operator, quality inspector, line leader, etc. Well-built control plans clarify not just what to do, but how to do it, as well as who owns it. Now let's walk through the steps to create a control plan from scratch. Step 1. Define the scope. Start by identifying the process, part, or assembly you're documenting. Be specific. Include part numbers, revision levels, and related customer or regulatory requirements. Step 2. Gather your inputs. Leverage your process flow diagram and process FMEA. These tools highlight the process steps and identify where the highest risks lie. Your flow diagram provides the process sequence. The FMEA helps prioritize which characteristics are most critical to control. Step 3. Document each process step. Use the flow diagram as your guide. List each step where product characteristics could be affected: machining, assembly, packaging, and even material handling. Step 4. Identify critical characteristics. Using the FMEA, select characteristics with high severity, occurrence, or detection ratings. These often tie directly to customer requirements or safety functions. Step 5. Define control and measurement methods. Describe both how the process will be controlled and how characteristics will be verified. Be clear and specific. Ambiguity leads to variation. Step 6. Set sample size and frequency. Don't just say inspect regularly, define it. For example, 3 parts per hour or first, middle, and last part each shift. Step 7. Develop a reaction plan. Ask, what happens if a measurement is out of spec? Include containment steps, escalation procedures, and documentation requirements. Step 8. Assign responsibility. Make it clear who does what: operator, technician, quality staff, etc. You want ownership, not confusion. And Step 9. Review and approve. Involve cross-functional teams: engineering, quality, production, even maintenance. Everyone should have input and buy-in. Creating a control plan is only half the battle. The real impact comes from effective implementation into your QMS. Here's how to do it right. 1. Integrate with existing documentation. Link the control plan to work instructions, inspection checklists, and standard operating procedures. Don't make it a standalone document that gets forgotten in a folder. 2. Train your team. Make sure everyone who uses the plan knows where to find it, how to interpret it, and what to do when things go wrong. Include control plan training in onboarding and refresher training. 3. Use visual aids. Consider visual control boards or tablets at workstations. The easier it is to access the plan, the more likely it will be followed. 4. Connect to non-conformance and CAPA systems. If a process characteristic fails, your control plan should guide the containment, correction, and root cause actions. This creates a feedback loop that keeps improving your process. 5. Establish review triggers. Set clear criteria for when a control plan must be reviewed: engineering change orders, process modifications, customer complaints, and audit findings. Let's cover some common pitfalls to avoid. Treating control plans as paperwork only. If they aren't used on the shop floor, they won't protect your process. Overloading the plan with every possible step or check. Focus on what's truly critical to quality. Failing to update after changes. A control plan is only as good as its last revision. Outdated info can cause big problems. Skipping reaction plans. If there's no clear action for out-of-spec results, defects will slip through. Excluding frontline employees. Operators and inspectors offer valuable insights. Involve them when creating and updating control plans. To wrap up, control plans are powerful tools that help you translate quality intent into execution. They reduce variation, ensure compliance, and support continuous improvement. When integrated into your QMS and actively used by your team, they help build trust with your customers, regulators, and within your own organization. Check out our other training videos in this series where we continue to delve deeper into the 6 pillars of total quality management, as well as tools, benefits, and how to implement TQM in your organization. Thank you for joining, and don't forget to subscribe for new videos from All Things Quality.